if we pick up at question 7, so y equals 4x minus 3, and we want to take the modulus of that. So if you just start off with, if you think of this as y equals mx plus c from GCSE, we know that plus c is where it crosses the y-axis, so I know I'm going to cross through at minus 3. I know I've got a gradient of 4, so I've got a graph that looks something like that. Okay, but the important thing is when we take the modulus, it means any negative part of the graph is now going to get flipped upwards. So my graph is going to look like that. Okay, and it does want you to mark the coordinates. We know that point there got flipped up, so it's now going to be 3. To work out this one, you are on the x-axis. So we know on the x-axis, y is equal to 0. So if you just put 4x minus 3 is equal to 0, 4x is then 3, and so x is 3/4. So I know that point there is 3/4. Right, find the complete set of values for which 4x minus 3 is greater than 2 minus 2x. All you're going to do is remember wherever there's a modulus sign, you're going to solve it pretending that's a set of brackets once where it's exactly as it's written. So 4x minus 3 is greater than 2 minus 2x. Please don't replace this with an equal sign or you're going to get the wrong results. And then you're going to solve it a second time where you put a minus in front and include brackets instead of a modulus sign. So solving this one, we'd get 6x minus 3 is greater than 2. So 6x is greater than 5, in which case x is greater than 5/6. And for this one, you get 4x and plus 3. So if I add 4x to both sides, subtract 2, and then half it, I get x is less than a half. Remember, that is two different regions. Sometimes you can put them together, and it might help if you think of it on a number line. Okay, so if you imagine taking from 0 to 1 on a number line and cut it into 6 sections. That was really badly cut into 6 sections. But we get 5, 6, 1, 2, 3, 4, 5 of the 6. And we want anything where it's greater than 5/6. And if you take a half and we want anything where x is smaller than a half, those two regions do not intersect. So they stay as two separate answers. If you get two arrows that end up intersecting with each other, that's when you do one combined region. Okay, if we look at question 8, find the binomial expansion. Now this is the one that we're still getting the same mistakes on. Okay, don't worry about this. This is just part of the notation. We'll talk about what that means in lesson. But ascending powers of x up to x squared. So first of all, I can write this as 9 minus 10x to the power of minus a half. Okay, minus because it's on the bottom, half is square root. I need to take out that 9. So what I can write that as is 9 to the minus a half, because remember the power goes with it, times by 1 minus, and then you get 10/9 x to the minus a half. 9 to the minus a half, first of all, minus is 1 over, so you get 1 over the square root of 9, so that just becomes a third of what you get from expanding that bracket. After that, you're just going to follow your formula. So if you don't know it, it is given in the formula book. We're using this one, 1 plus nx, n minus 1 over 2 factorial x squared, and so on. Okay. So what we get is your n value is this term. Okay, so minus a half. Your x value is everything you get there, including the minus sign. Okay, so what we get is a third of, we've got 1 plus n x, okay, plus n minus 1 x squared, and it is the whole term that's being squared, over 2 factorial. We're only going up to x squared, so that's as far as I need to go. If you expand those things out, what you're going to get is a third of 1 plus 5/9 of x plus 25/54 x squared. Okay, and then all you need to do is multiply through by a third. You get a third, 5/27 x and 25 over 162 x squared. Okay, if we look at the expansion of this then, so all that's different between what you've just done and this one is you've got a 3 plus x on the top. So you could think of it as 3 plus x multiplied by, and then 9 minus 10x to the minus half. This part you've already expanded. So I get 3 plus x multiplied by everything we've just worked out there. And again, we're only looking up to x squared. Okay, so the minute we get any terms bigger, we can ignore those terms. So if I multiply all of this through by 3 first of all, I'd get 1 plus 5/9 plus 25 over 54 x squared. If I then multiply them all through by x, I get a third x, 5/27 x squared. And if I times x by this one, I'm going to get an x cubed, which I'm not interested in because I'm only going up to x squared. At this point, you're just going to collect them together. The only whole number is 1. 5/9 plus a third is going to give us 8/9. And then 25 over 54 plus 5 over 27 is going to give us 35 over 54 x squared. Okay. Right, question 9. These ones, if I just double check, are you given any formulas? You are given the sum formula for arithmetic, but you are expected to know the standard formula otherwise. But we've got the sum of the first 10 terms is 162. So I know the sum to 10 equals 162. We want to show this equation. So our sum formula that is given in your formula booklet is a half of 2a plus n minus 1d. So if I want the sum to 10, I know 162 has to be equal to, and because we're replacing the n with 10 anywhere in here, we're going to replace n with 10. So I get a half of 10 is 5, bracket 2a plus 10 minus 1 is 9, so I get 9d. It is a show that question, so make sure that you expand this out and tidy it up. 162 is 10a plus 45d, in which case we've got exactly what they asked us for. Given also that the 6th term of the sequence is 17. Now remember, for a term in a arithmetic sequence, it's un equals a plus n minus 1d. So that's one of the formulas you need to learn if you haven't already. Okay, so I know that u6 is 17. Write down a second equation. Well, that means 17 is equal to a plus, if n is 6, 6 minus 1 is 5. There's your second equation. Find the values of a and d. You've just got a pair of simultaneous equations. So we get 10a plus 45d equals 162. And if I multiply this equation all the way through by 10, I get 10a plus 50d equals 170. In which case, I'm just going to do the bottom row subtract the top row just to keep things positive. So those are obviously going to cancel each other out. 50 subtract 45 gives me 5. 170 minus 162 gives me 8, in which case d is equal to 8/5. And then I can plug that back into one of my equations. I'm going to use this one. So 17 is equal to a plus 5 lots of 8/5. If I do 5 times 8/5, I'm just going to get 8. So 17 is equal to a plus 8, in which case a is equal to 9. And that's it. Question 9 done. So if we move on to question 10. Geometric sequence. Now, again, the sum formula and the sum to infinity are given for geometric, but you need to know the general formula for geometric sequences. This one is the sum to infinity is 6 times the first term, and it tells you that the first term is a. Okay, in which case the sum to infinity is given in your formula booklet as a over 1 minus r. So that means we know that a over 1 minus r is equal to 6 lots of the first term. And then all we're going to do is multiply by the bottom. So I'm multiplying by 1 minus r. And we're just going to rearrange and get r. So if I expand the brackets, I get 6a minus 6ar. If I add this to this side and subtract a, I get that 6ar is equal to 5a. A is in everything. So I get 6r is equal to 5. And then if I divide by 6, r is equal to 5, 6, which is what they asked us to show. Right, given that the fourth term of the series is 62.5. Now remember, this is not the sum of the first 4, it's just the fourth term. So that is, a is the first term, ar is the second, ar squared is the third, ar cubed is the fourth, and so on. So because we want the fourth term, I know that ar cubed has to be equal to 62.5, and we know what r is equal to. So I get a times 5/6 cubed equals 62.5, and then all you're going to do is divide through by your term. You get a is equal to 108. Okay, find the difference between the sum to infinity and the sum of the first 30 terms. Okay, so if we do the sum to infinity is a over 1 minus r. So that is 108 over 1 minus 5/6. You get 648. If I do the sum to 30, you're going to use the formula that they give you in the formula booklet. So a lots of 1 minus r to the n over 1 minus r. So we get 108 times 1 minus 5/6 to the power of 30 over 1 minus 5/6. Type that into your calculator, you're going to get 645.270. And then all we want to do is we want the difference. So sum to infinity minus the sum to 30. You get a difference of 2.7298 and so on. 3 significant figures, 2.73. So 3 significant figures. Okay, and again, I'm going to do a video for the next ones.